Hello everyone, my name is Matt Rule, and today I'm going to be talking to you about paper bridges. First, the original design activity that I looked at, this activity was an all-encompassing activity. Students were given folder paper, tape, and scissors, and the students were instructed with those materials to determine the best shape and design for a paper bridge. Once the students had designed their bridges, they constructed it out of the given folder paper, and each group tested their bridge with a force sensor, and they would then graph the results and see which design held the most amount of weight. My activity, on the other hand, uses a more introductory brainstorming type of activity. It gives each student a 11 by 17 piece of paper, tape, and scissors. I have the students design a bridge determining the shape, size, length, etc. The students will then construct their bridge with the given materials. Then we will add weight to each bridge using golf balls to determine which can hold the most weight, allow them to alter or improve their designs, and that's when we would transition into building their bridges out of wood. So, STEM practices involved. First is asking questions and defining problems, like what is a successful bridge design that will hold the most weight. Developing and using models, the students actually building their paper bridges. Planning and carrying out investigations, so the students will actually test each bridge to see how many golf balls it's able to hold. Analyzing and interpreting the data, so essentially seeing which bridge held the most amount of weight, what design, and why. Using mathematics or computing thinking, basically calculating how many golf balls it was able to hold and how much weight that equates to. Constructing explanations, having the students discuss why they think a certain design did or didn't work well. Next is engaging in argument from evidence, so having the students justify the modifications that they would make, and obtaining and evaluating and communicating, so basically communicating and justifying why those changes are necessary. Inquiry practices. The first is learner engages in scientifically oriented questions, such as what type of structure will allow the bridge to hold the maximum amount of weight, what changes could improve the design, what priority to evidence in responding to questions, so the students will conduct tests on the bridges to see which one is able to support the weight. Learner formulates explanations from the evidence, so looking at the data and how much weight it was able to hold, which design worked best. The learner connects explanations to scientific knowledge, so why does a certain design work better than another? And learner communicates and justifies explanations, so once again, why did you make the changes to your design that you chose to? So the supplies for the activity are the paper, scissors, tape, and golf balls. The competition is my wife and I. And our designs, initially mine on the left, my wife's on the right. You can see the designs that we both came up with. Here's the construction phase of us cutting out our strips of paper to make our bridge designs. And then here are our completed bridges. Once again, mine on the left, Rachel's on the right. And then it was time to test them. What we did was put them in between two chairs and added golf balls to the shopping bag for weight. Mine on the left held 3 golf balls before folding over, and Rachel's held 2. So the calculations involved, my bridge was able to hold 4.86 ounces and Rachel's was able to hold 3.24. And reflection or redesign, I would make additional cross beams to try to help my bridge from tipping to the side, and Rachel said she would also reinforce her design to keep it from tipping as well. So that's my experiment and what I would change. Thank you for listening.